So we've got the northern lights, and they are above the Earth, and we're going to say they're above 150 miles above the Earth. They want to know, put in red here, the measure of that arc. In other words, what part of the Earth, you could figure out what percent of the Earth could actually see them based on their circumference there. Okay, so that's what we need to know. And a couple other things we know, but we don't necessarily aren't specifically told. Well, they did say that, but this is a radius, and that's a radius. Okay, so we've got that. They share AC, and we know that these are these are tangent points. I wrote it in here, but they are tangent points because they're only hitting once. So this is a right angle, and this is a right angle. And so what that means is we can say that the triangle ABC is congruent to triangle ADC by hypotenuse leg. Okay, which then helps us because it says this is the same distance as that. Okay, and we also know that from some other theorems earlier in the chapter, that 2 points of tangency from a common point will be equidistant. Okay, so we know that that's the case. So that should help us with some stuff here. So let me erase all this off. Okay, so we're back to where we were, and what we're trying to find is BD right there, and I'm going to call that, we're going to call the measure of arc BD equal to X. Okay, that means there's another arc I'm drawing in yellow around the Earth. Arc it's a major arc, BED, is 360 minus X. I don't know if you can read that. I'll write that again. Wrote it in black. 360 minus X is the other arc. Okay, so in a sense here, we have the two tangents external. We're going to do a difference on it. And so I'm going to write okay, so if we want this angle here, so the measure of angle C is going to be half of 360 degrees minus X degrees. Okay, put it like that, minus X. Okay, so we've got that going there, but it's just not that helpful for us right now yet. So we get, when I simplify this, 1/2 360 minus 2x, I get the measurement of angle C. It's 180 degrees minus x when I bring that in there. Okay, so it's still not done yet, but we know some information there as well. So I'm going to rewrite this. I'm going to rewrite that in a second here. So before I erase the screen, I had the measurement of angle C, I have it in the top right corner, equals 180 minus x. Okay? The problem is getting C. Well, remember we have this right angle here. We have that right angle there. And if we want, we know that these are congruent. So if I want half of C, so I call it the measurement of angle. So wait, I'm going to change that. I'm going to call that angle theta. So that is theta. That is theta as well. Okay, and if we have angle theta, we know that this is the opposite, and we know that this is the hypotenuse. So which trig function uses for theta uses opposite and hypotenuse? Well, that's sine. So opposite over hypotenuse. So we know the sine of theta is 4,000, the opposite over the hypotenuse. Okay? So what we really want is the arc sine. If we want theta, we want to arc sine that fraction. So when I do that on my calculator, second arc sine 4,000 divided by 4150. Always check your mode. My mode is fine. We're going to get 74, and I'm going to estimate this 0.55 degrees. What we really want is angle C, which is 2 theta. Okay? So we're going to get the angle C is, I'm going to double my answer here. And I'm going to get 149.1 degrees. So we're going to carry that up. So I'm going to carry this up to the top there. I'm going to put 149.1 degrees equals 180 minus x. And if we do some work, subtract 180 from both sides, we'll get negative 30.9 degrees for negative x. So we can get our final answer for x is 30.9 degrees. So this arc here is 30.9 degrees.